Okay, 10 has a region that looks like this, as best I can remember here. Okay, 10, right? Okay, the cross sections are semicircles. What I keep trying to remind you is, you don't really care what the three-dimensional volume looks like. All you care is that you know what the slice looks like. Because you're not really finding the volume of the slice, you're finding the volume of the solid, you're finding the volume of the slice. So now the slices have this shape, they're semicircles. So the slices look like this. But when you pick up the slice and lay it on that, this edge right here, this edge of the slice, that's what sits right like so. And so the slice, you can't really see it in a two-dimensional drawing because it's coming out of the board. But you don't care. All you care is, I now know what the slice looks like. So I focus all my attention on the slice. Okay, this is the diameter of the slice. The radius is half of that. I don't like using radius in these problems because you get way too many fractions and it can cause errors. So I use the diameter. So everyone knows that the area of a circle is pi r squared. Therefore, the area of a semicircle is that divided by 2. Okay, real quick formula derivation. Diameter is the same thing as the radius times 2. Therefore, the radius is the diameter divided by 2. Okay, I like using the diameter because the diameter is what I see here in red. This is the diameter of the slice. In problem 10, do they label the top function as f of x?
Yes.
Okay, so I know the red length is just f of x subtract g of x. Because it's the y-coordinate at the top, subtract the y-coordinate at the bottom. That's the diameter of one slice. Wave if you need me to talk through that again. Okay? So that's the diameter of one slice. We'll look at this formula. This is how we're computing the area of the slice. We're taking the radius squared times pi divided by 2. But if we write this formula out, here's what we get. Pi over 2, d over 2, d over 2. Okay, it doesn't matter how we multiply, so I'm going to multiply all the 2's first. Therefore, we get pi over 8 diameter squared. So this is the formula I prefer to use on the AP test. It's less prone to error. So here's my diameter. All I have to do is square the diameter, multiplied by pi over 8, and I have found the area of one semicircular slice. Which slice depends on which x I plug into the formula. Therefore, I'm going to integrate from 0 to whatever this x-coordinate is. Don't forget to multiply by the thickness of the slice. Please.
So is the d squared just the f of x minus g of x of diameter of x minus g of x, right?
Yeah, it's just the same. Good questions. 2 points. It's just the same concept over and over again. I need to find how long this vertical line is. So I take the y at the top, subtract the y at the bottom, and then plug it in your calculator.
Are the slices always perpendicular to the x-axis?
In the future, we'll work with some problems. They're not nearly as common. I would say perpendicular to the x-axis, there's about a 90% chance they ask that. About a 10% they say perpendicular to the y-axis. We'll not worry about this for now. When you get good at perpendicular to the x-axis, I'll show you a trick to answer the other question. It's not too bad. So. Questions here? Stop that.